Okay. So for this case study, this is what we will use. Okay, so there is a CSV file, and so there is a school code. So it will be like 2 byte district code followed by some number, and then a student ID, and then a last name, first name, gender, date of birth, and then you have 5 scores, right? Language 1, language 2, math, science, and social, and then a status or a grade, which can be like average, pass. Okay, so these are the, let me put it on the top. So these are the 13 fields: school code, student ID, last name, first name, gender, date of birth, the 5 subjects, a performance level, and then end of the record. Okay, and what we are going to do is we will take the first field and then get the first 2 byte, which is a district code, and then we will get the 12th field, and then we will use these two to aggregate, basically the count. Okay, so so we have these many levels like absent, advanced, average, pass, proficient, and read, which is another name for fail. Okay, and then there are these many categories. So we are going to have a table that will show you for each district what is the number of absenteeism, number of pass, number of fail, number of proficient tests, number of average scores, which is based on how much actually the actual score is. And the result will look like this. So Tamil Nadu, some header, and then each district. Then you have the absent, redo, pass, average, and then advanced, right? So this is the report we are looking at. And so this is formatted. So this is something that is already written using a custom logic. Okay. And the other two things we need to look at is how do we load the CSV file that we saw. Okay, this one into an SQLite database and then run a query inside the Perl script, iterate the results, and then create a report like that. And also load the CSV into a pandas, using the pandas module, and how we use the methods provided by pandas to analyze the data so that we can bring the same results. Okay, so the idea is to concentrate on how to bring the results. The exact way which we are printing, it's irrelevant. Okay. So I will load a sample data set and then the output today itself. So that like you can take a look at it. And so you already know that this was created using the Faker module. So you can create your own stuff. Probably think of something like when I discuss about the 3 different ways of doing some data analysis, you can think of your own data, which can be something that you can create, or there is ample amount of data that is available online, like rainfall, temperature, population by country, population by different provinces or state or districts within each country. So there are data available from the United Nations websites, and then US government, Indian government, and there are a lot of data even available from AWS, Google. So there are ample amount of public data available, which you could utilize to probably mimic something that we are currently doing, and then from there you learn and then go for advanced, like the other usage from these modules. Okay, so this is what we have in store for the next 3 days. Okay, and yesterday we mainly concentrated on how to write user-defined functions, the syntax, how do you code parameters, what are the different type of parameters that are available, which is like positional or a required parameter, and keyword parameters, default parameters, and variable number of parameters. In that variable number of um, like positional parameters, and then variable number of keyword parameters. And also with an exercise that I have given you, in case if I need to have a mix and match of keyword, positional, variable number of keyword argument, variable number of positional arguments, what is the order? Does the order matters? Okay, that's something I left it to your own study and understanding. So that is what we did, right? And then we did a quick look about how to create a module, and then write some test code within the module itself, how to import a module, and then how to use the methods available in that module. So that's what we have seen yesterday. Okay, and then the previous sessions, so we talked about various data types, conditions, loops, and file handling, and processing from a directory, get a list of file, and then processing multiple files, right? So we also saw uh, a set of files which can constitute a case study where generating random data, generating multiple files, and then split and merge files, and then do some basic transformation. Okay, so we have come a long way, and after the rest of this 3 days, you should be able to continue the journey on your own. So depends on what interests you. Like from after the end of the session, you can branch out to various areas. Like you can go into web development using modules like Django, Faker, sorry, not Faker, Bottle or Flask. Or you can get into data analytics using NumPy and then pandas. So you can get into report creation using reportlib, or you can do visualizations like Plotly or matplotlib, and so on, right? So there are several areas which we could take. And also, so if you want to get a good understanding of these concepts, maybe you could spend some time understanding how object-oriented programming is done in Python, right? So this is what we have seen, and then this is what you have in front of you as opportunity to learn, and then become an expert in certain area. Right? Or if you are just interested in automating stuff and then creating test data, if you're a tester, then whatever we have seen is enough, that using that you should be able to create some sophisticated scripts to create data using modules like Faker, and then creating your own functions to generate random test data. Right? So you can create a set of functions and then create your own model. So whichever way you want to go. So this series would give you an adequate foundation to proceed further. Okay. So first thing that we would look at is exception handling. Okay. So far when we ran our script, we simulated some errors, like trying to add an integer and string to show you how Python when it passes or like when it runs a particular statement, if it finds something incompatible, then it throws an error and then it stops there. And then we also saw some syntax error when I missed a semicolon, not semicolon, colon in a for loop, or missed a quotation, quotes, or misspelled a particular keyword, right? So those things were there, and so we didn't do much about it except run the script, correct it, and then go, right? So now what we will do is we will actually take a look at what is that, how it is getting produced, and is there something that we can do about it. Okay. So first of all, you will encounter syntax errors, right? So like a missing quotes or a missing close parenthesis or a missing colon and then so on, right? Or indentation errors, like you haven't indented things properly. But those are syntax errors, right? So the only thing that you can do to proceed further is to fix those, right? So for example, right, I have a print function, and then I forgot the closing parenthesis. I get a syntax error, unexpected end of file while parsing. Okay, it doesn't say that I am missing a semicolon, I'm missing a close parenthesis. It's simply trying to parse. So it starts with the open parenthesis, and then it goes, and then it tries to find the close parenthesis. It is not able to find it, and then it's saying I have reached the end of file, and my parsing is still not complete. Okay. See, a lot of times when Python says there is an error in this line, when it comes to syntax error, you will have error somewhere few lines before, because the position where the error occurs, Python probably read past it, and then it comes to a place where it can't do anything about it, and then stops and complain. Okay. So this is one such case. Okay. So the second thing is missing quotes. Okay, so both the same statement, we missed two different things. So here it says end of line while scanning a string literal. So it starts with open the first pair of double quotes, and then it got hello, and then it got a closed parenthesis, and then the line ended. Right, so because the double quotes, single quoted string is for single line string literals, and then I didn't see a closing quote. So it is saying my end of line has reached, but I am still not seeing the closing quote. So this is another syntax. And the third thing is I missed a colon here, so it is saying invalid syntax. Okay, because the while, for, if, elif, else, def, and all those things are like a header statement followed by a set of sub code blocks that's part of those header. So the syntax is it starts with a keyword and then something in between and then ends with a colon. So it is giving me that error. And here is the indentation error. Okay. So while whatever you are supposed to run under while has to be indented, and then the print statement is not, and then it is giving you error. Okay. So these are some of these errors that has something to do with the syntax. So Python, when you install Python and then when you learn, so you implicitly agree to follow the syntax, right? So Python says these are my keywords, you cannot use it. Or these are my operators. So these operators expect these kind of operands. You have to write like my variables are case sensitive or my keywords are case sensitive. So there are several things. The way Python understands, so you implicitly agree to that. So anytime you violate that fundamental concepts or like the syntax or definitions, so you will get these syntax errors. There is nothing we can do about it except you fix it. Okay, there is a second category, so which we call them as errors or exceptions. The syntax is correct, so that means the Python is able to parse all your statements okay, but there is a problem in executing it. Okay, some of these problems, for example, like you have a division expression, and then in the runtime the denominator is 0. So as per mathematical principle, we cannot divide a number by 0. If you divide, then the number will be infinity, and then infinity is something that is not very useful in handling things here, right? So that is one thing. And the second thing is, so you have a list that has 10 elements, and for some logical flaw, you are trying to access the 11th element, right? So instead of making the last index as length of list minus 1, so you are trying to iterate from 0 to length of the list. So there is an index out of bounds error. And trying to do operations with incompatible data type. For example, adding a string and an integer, or multiplying two strings, right? So in that case, so you will get incompatible data types. And finally, not last but the least, like there is a file operation. You try to open a file for reading. Either the file doesn't exist or you don't have permission to it, right? So in these cases, if you let Python have its way, the execution stops there, right? So handling exceptions gives you two opportunities. One is it gives you an opportunity to exit the program in your own terms. In the sense, like instead of getting exposing the end user to a bunch of statements, which even sometimes confusing to us developers. So you could handle the exception and then exit gracefully with your own custom messages, right? The second option is, okay, these problem occurred, but this is not a showstopper, right? For example, so there is a calculation that requires division, and then you got a 0 as a denominator. But 0 is still an acceptable value, or null is still an empty string is still an acceptable value. So you catch this situation and then you assign a default. So in that way you can continue, right? So either a graceful exit or remedy the situation and then continue this. So that is called exception handling, and Python provides 3 keywords or like 4 keywords to handle these exceptions, and there is one keyword you can create your own exceptions, like the way Python is creating exceptions like zero division error, name error, type error, and so on. You can actually create your own exception. The thing is that you can raise an exception and then you can create your own exception. For example, let's say you have a field called scale score. Okay, scale score is something that is a derived score, right? Like you take some competitive exams, and then each question will have different weightage assigned to it, and then the scale score for that exam is the minimum is 300 and the maximum is 600. Okay, and then you are receiving the scale score through some external vendor. So you are looking into the field, and then the value is either less than 300 or greater than 600. Okay, so what you can do is, so you can write your own exception called scale score out of bounds exception, and then you can have a method read the value and then it raise the exception. So that means you cannot only handle exceptions, you can also raise exception. In that case, it is somebody else's responsibility who is using your script to handle. Okay, so that's the basic concept. Okay, so here we have the zero division error, and yeah. So this one, I think, let me take this. Right. So we have there is numerator is 10, and the denominator we are trying to create something, but we had a issue in the logic. So we create a random number using the random method. So, but what this method does is it will give you a number between 0 to 0.999 something, and then we are trying to make it as an int, which will be 0. Maybe you wanted to add something, or you wanted to multiply this value so that you will get a range. For example, you want to get something between 0 to 5. You multiply this random with 6. So you will end up in getting some number anywhere between 0 to 5, right? So you might have forgotten that. So then denominator is 0, and you are trying to do a division, and then you get 0 division error. Okay, so this is something that is thrown to Python. The second thing, so you have the value 1, and then you have a string 1 you are trying to add, so you have unsupported data type. Okay. Okay, so here is so I have given in this example what is the expression, right? So here if you look at it, so Python provides something like this, right? So this is the stack trace. So it will give you some sort of arrow like this in case if you can point out where it is looking into the error. And then here is the exception. So we saw here 0 division error, but it actually tells you 0 division error and then trace back and then which module, and then it gives you some of those statements and then put some arrow which expression caused it, and then it will give you error message. So this is what your user will get exposed to, and sometimes this can be really very big also. So that is the reason it is important, especially in modular programming, like when you create modules for others, or when you use somebody else's module, right? When you create modules, you make sure that you handle exceptions, and when you use others module, like see where exceptions are raised, and then you handle it accordingly. Okay. So we will use the try, except, and finally blocks. So try statement is what we will use to handle exceptions. So instead of normally executing the statements, which might cause errors, you will put it under the try block, and then you will get it executed. Okay. If there are no issues, then that's it. The statement is all done. Then you can go on to process subsequent statements. If there is an error, the except block will get executed, right? So that is where you handle the exceptions, right? Maybe like you assign the result of a division to 0 if there is a 0 division error, and then keep going, right? So there can be more than one except block. So that means you can specifically handle certain errors. Okay, like if there is a 0 division error in an arithmetic operation, you can do that. And then you can also have a generic except block which can handle any exceptions, right? It's like a catch-all mechanism. Okay, so that's the flow. And there is another keyword called raise. which you can use to raise your own exception. So in the sense, like I said, right, if scale score less than 300 and scale score greater than 300, raise scale score out of bound error or exception. Okay, so scale score out of bound exception is our own. So we can do a raise. So when somebody is calling this particular method, they will get that. So they can put our check in a try block and then they can handle it. Maybe they will say that, they will set a different field, not tested or something like that. That finally class, right? So you have try, you have one or more excepts, and then you have finally. So finally get executed no matter what happens, whether the try had any issues or try had no issues. So this is a good way to make sure that like your program exits gracefully if it has to. For example, like you have several files that are open, so there is an issue. So you make sure that those files were closed, right? So finally is a place where Python makes sure that even if there are some errors, that code block gets executed. So that sense, so you can control over freeing up resource and then cleaning up before your program exit, right? And there is also an else class that you can code. The else class is like finally, but it will get executed only if there are no issues. So you want to do something when there are no issues, then you can code that sort of statements there. So if you code a try statement, this is the order. So you code a try block, which is mandatory, and then you put all of the statements that you want to execute, which may produce exceptions. And then you code one or more except block, right? And then you code an else block, which is optional. And then we code a finally block, which is optional as well. But when you code all these things, it has to be in this order. Okay, I will have examples below that shows like what if you don't follow the order. Okay, so now I have an example of exception handling. There is one scenario. There is a file that doesn't exist, right? So I have this block, and then the second scenario is I create the file, but the file is empty. It's trying to read something and then there is an error. The third scenario is I put something in the file, but I am doing a division operation where the denominator is 0, and then what happens? So we slowly see how these things happen. Okay. So first thing what I'm doing is I am doing open my file txt. I do a read line, and then I convert that whatever I read into a integer, and then I divide it by a value x, which x is not there, right? So any of these statements can cause issues for us, right? So first is I'm just looking at OS error. Okay, so my file is not there, so I'm just trying to capture that. So if it's OS error, and then I'm saying, hey, there is a OS error, and there might be a message in ERR that comes as a part of OS error. Then we say, okay, I have OS error. Right? Then there is a value error because my file is empty. The I equal to int s dot strip. This line might have issues if the file is present, right? So I'm just saying could not converted data to an integer. Maybe I have an integer, or maybe my file is empty, right? And then finally there is an unexpected error, right? So first time, so I'm not going to execute it again. First time what I did is I just simply ran it. So I have OS error number 2, no such file or directory called my file.txt. Okay, first time. So if I ran without anything, it would have given me some error and then it exit. Okay. So now what happens is if I want, I can still continue the code. So then what I did is I am running a system command called touch. So if you are familiar with the Linux command line, touch is the command that creates a file if it is not present. Otherwise, it will simply change the access time of it. So it creates an empty file if there is no file with that name. Otherwise, it changes the access time. So now the file is there and then the file is empty. So it is saying this error because this line, right, int I equal to s dot strip caused the value error because it is trying to convert an empty string into an integer, which is causing this issue. Okay. So then what I did an echo 100 to my file. Again, this is another Linux command that simply prints whatever you give after the echo command. And then I use the greater than symbol to put that value into my myfile.txt. My myfile.txt has the value 100. And now it is trying to divide it by x, which is not there. So when a variable is not there, it will cause name error. So it goes here and it says unexpected error called name error, and then it is printed whatever information you have, and then finally it goes, it just ends. Okay, so if you look at it, so the same statement executed 3 different times. Each time we fix one issue, and then you see how the error cascades. Now if I simply put like x equal to we say x equal to 3. If you look at it, 100 divided by 3 is 33.33. So now, if you look at these 4 different statements, right? Okay, we can do one more thing. Okay, so let me delete this file, my file.txt, right? And then we get a file not found error, no exception handling, file not found error, right? So and then we go here, so it is handled. Okay, so when you see things like this, your program stops, right? So now we get an error. So I can even demonstrate that. So if you look at it, there was an error, like unlike before, since we put it as an except, and then in that except we are not exiting. So it still goes out. So if you want to continue with some default values, you can still do that. Okay, so now I am doing a touch. The file is present. So if you want to see ls, so you have this myfile.txt. Now if I run it, I could not convert an integer because so there is no value. Now we are adding the value. So we are trying to add here. Do a del of x. So here you have a name error, and then finally there is no error. Okay. So any question? Again, just another disclaimer. okay, so there are chances that you may not need to do exception handling a lot. Okay, so there are other ways where you can always have some if conditions. So exception handling is very useful when you're writing common modules or object-oriented programming way. So you expect these your modules or like your functions to be used by a lot of people, and then you can you can in the documentation you can produce things like, okay, so you use this, but you expect this exception to be handled. So in that way, so you write a robust code. And also normal scripting. So whenever there is a file that is not found, you want to have a default file name or something like that, you can do that. Okay. Otherwise, if you think that these concepts go out of just fly out of nowhere, then don't worry about it. Okay. So, but still, this is one of the basic construct in Python. So as a part of the syllabus that I covered. Okay. Any questions?
Is there any hierarchy for the handling? Just like
What
the
is that?
Java, but any hierarchy for the exception handling? Just like the Java provided the IO exception or exception classes.
Right. Yeah, there is a hierarchy. If you look into Python error handling, so exception is the basic class, and then from there you will have this arithmetic exception, and then within that you have zero division exceptions and so on. So there is documentation available if you want to know the hierarchy of exceptions that that the Python produces.
Okay.
Okay.
Yeah.
So anything else?
And finally is also available, just like the opening of file and then
Yes,
exception
finally is
handling.
available. So if you look at the screen, so that is what we are going to discuss next,
Okay, fine. Yeah.
right?
Yeah.
So now it is not an error. So I am just going to show you what are the possible constructs, right? So okay, first thing what I am going to do is I am going to explicitly delete the variable called name, and then I'm just going to run this. Okay, so I have a except, I have a else, and then I have a finally. Okay, so when I run this, I have a name, and then I am deleting. Okay, so just to make sure that that variable is not there. So we are trying to do a print statement with that variable, which is no longer there. So it is causing an exception. So that's why it came here. So we didn't handle this exception. We simply printed. Okay, just to show like when this happens, where the control is coming. Okay, so this ran. There is a problem. So this ran, right? Okay, maybe I'll put this also print. Right. Okay, so I'm in try block. So the print had an issue. It came to an except class, and then it said exception occurred, right? And then it also did the finally. Okay, so this is what finally is for. No matter what happens, whether the name is there or name is not there, this finally is always going to run. So that means it is a fail-safe mechanism for you. So if you want to do something in case of error, you can do it over here. So if you want to do something else, if there is no error, then you can do it over here. Okay. So this is like a cascading, like the flow. So in that way, you cushion the effect, right? So there is a statement or set of statements that needs to be executed. You are looking at two scenarios. These statements execute fine, and these statements may have issues. So if you have issues, then there is an except. If you don't have issues, then you can go out of the statement, or you can do something else. If there is an issue, maybe you want to do some cleanup. So in that way, you can go to the finally, whether you have issue or you don't have issue. So that's why you were in try block, exception occurred, except block ran, and then finally also ran. So now if you take a look at it, so I have the name now, which is available. Okay, so let me put this one here. Run it. So I am in try block. I executed the statement successfully. Except is not run, and the else block ran. So else will run only if the try block is successful, and then finally will run no matter what. Okay. So in this scenario, the very first scenario that we saw, try ran, except ran, and finally ran. So in this case, try ran, else ran, and then finally ran. Okay. So else will run only if your try block is successful. Finally will run no matter what. Okay. So these two can help you code some statements. So in case there is no issues, in case there are issues. Okay. So now there is the order that we saw, right? So we code the try block first, we code one or more, except we code an else, and then we code a finally. As the name suggests, finally has to be the final block. So I try to put the else at the end, it is giving me syntax error. Okay. So I put else, if you code an else has to be after the last except statement. So I code the else first, and then it is giving me a syntax error. And here, so you coded in the right order. So I have the name, del name, and then it ran the try block, right? And then I have two except statements. So this is a name error, okay, because the name is not there. So it just printed whatever is available. Okay, it didn't run this part. It ran this exception. Okay. So and then order of handling exception. Okay, I have a variable called z, and then I divided by 0. Okay, so there are two issues here. So I have a name error, and then I have a 0 division error. Okay, so if the variable is there, then the 0 division error will occur because we are explicitly dividing it by 0. If the variable is not there, name error will occur. Okay, so depends on which error occurs first and how it is coded. In that order, Python handles the exception. Okay, so it's still the same thing. I'm just saying z equal to 10. Then we have 0 division error, right? And finally, so when we did file handling, in one of the situations when we did the case study, I might have shown you this logic. So instead of variable equal to open function, so with open and then as variable, then I might have coded something like this. Okay. So this is an implicit file exception handling. So the advantage of opening using the with block is when the block is completed, no matter whether there is an error, whether there is no error, the file is always closed. So that means you don't have to put this in a try block. So you can simply make sure that when you code like this, whatever file that was open, and if there is an error while processing the file, you can be sure that the file is always closed. Okay. So here we have ample examples, and you can always look into Python exception handling to get the list of exceptions that is supported by Python. and there are enough materials available how to write your own exceptions. So, okay, so here is some information that you might be able to utilize when we go out there and write programs in your project. Okay, so if this is all too much for you, take it slow. Just remember those keywords: try, except, finally, else, and raise. So those are the 5 out of 35 keywords that is provided in Python to deal with exceptions, either to handle it and then continue your code, or exit gracefully with your own messages rather than throwing or accepting whatever Python has to say about the error. Okay, so that's exception handling. Okay, so the second topic, again, this is much more smaller than the previous one, is going to be parameters. Okay, so just like the way we saw that functions can have parameters, so what Python provides is that you can pass parameters to your code itself. Okay, so as the parameters make the program dynamic, sorry, the function dynamic, versatile, and handle more functionality. So there is the parameters that are available, which will help you handle, write more robust and dynamic code. Okay. So let's say you have to pass like 5 values, which may change runtime. Okay, so you have 2 options. One is like code these variable names on the top of your script. So every time you run the script, you go and change the values, which is something I do very frequently for smaller things that I alone run. Okay, but let's say your script is in a source control system, and then it follows a deployment procedure and stuff like that. Then it will get difficult, right? So what we can do is we can pass these 5 values as a parameter, and then you can accept it, store it in a value. So that means anytime you can run it with any value you want to give, right? And inside the code, you assign it to a variable, you want to do some validations, you can do that, right? But the thing is, your program doesn't have to change every time you have a change in some of those values, mostly the file names and things like that. So if you remember, when I showed you the code that generates the test data for the Arduino fine speeding check, so I have put the start date as 2009 December 31. So that, like, we will generate 1 file per day from 2010 January 1st onwards. And then it will, the end date is also hard coded, that to be April 30th. What if I don't want to do that? What if like I want to control my own date? So I can do that. So how we can do that? So we will pass something like this: Python script name, and then I have one parameter which is the start date, and then the end date. Then I am giving minimum number of records I want, and then maximum number of records I want, and then my folder or directory where I want to create the file, and then finally my file format. Okay. So this is something I can do. Okay, so where is that? So if you look here, not this one. Yeah. So this is the thing that we have seen, right? So if you look at here, so this is my first hard-coded data, right? Start date. And this is my second hard-coded data, end date. And this is my third, fourth, and fifth hard-coded data, my location and my file name, right? And then this is the third and fourth hard-coded data. There are 6 hard-coded data here: the start date, the end date, the minimum number of records I want to create, and then the maximum number of records I want to create, the location where I need to create the file, and then the file naming convention. Okay, so these are the things I have hard coded, and here we are making this as parameters. Okay, so we still need to handle something, but the thing is, let's say I have to decide, okay, so I don't want from 2010, this is lot of files, and 2015. So I might have to go here and then say change 2014, December 31. So not April 30. I want to generate from March 31 only. So then I have to go and change it here. Then I find there is 500 is not adequate data. I want at least 5,000 to 20,000 records. Then I have to go and change here. So now this is the obvious thing. I gave you this code, you run it, and then it will say, hey, I don't see a folder called users. Maybe you are running in a Windows machine, right? So that means every part of the thing can produce error or not produce error, can subject to change, depends on your fake data creation needs, and here it is all hard coded. So the parameter processing can help you avoid that. Okay, so when we code like this, then how do you receive? So first thing is we need to import the sys module, sys as in system, so you can get access to system parameters. So in that there is a variable called argv. Okay, so argv is something that you might be familiar if you are from the C++ background, right? Argv and argc. So this is a list which will contain the parameters that you have passed. Okay, so you need to be aware of what this list can contain. The very first element in the list is the script name or executable that you are running. So if you run a script, that's what it is going to have. Then the subsequent values will be the elements that you have passed. So if you see here, I have a simple program. I will show it shortly. I will execute it with the same value. So what it does is it imports, and then it says script equal to sys.argv of 0, and then palms is sys.argv 1 colon. So this is a list slicing from the first element all the way till the last element, first offset to last element we will take it. Or you can simply say sysargv.pop of 0. So this statement will remove the first element from the argv array, and then it will put it in the script, and then the rest of the elements are going to be your parameters, right? So I ran this. So it says my parameter is this, and then these are the values that are passed. Okay. So I'm just going to take this and then run it. So it says I have 7 parameters passed, and then my script name is this, and then my parameters are this. Okay. So if I look at 0, 1, so I have, that's all I have, right? I also have same thing. So I have 7 parameters passed, and then since it is a pretty print, it prints the value one line at a time. So you see it over here. So that means like once you have the value, you can assign it an appropriate value, and then you can do validation. That the date has to be that, and then my min value has to be a number, max value has to be a number, and so on, right? So, but the thing is, these are like positional parameters, right? So there are 6 parameters, and then if your code expects 6 parameters, then you have to pass it. Otherwise, you might have some runtime errors, and then you have to pass it in the same order, right? So some of you might be might have worked on the Linux environment, so you are familiar with the way when we run the commands, we pass some options, we pass parameters in a certain way, right? So in case if you are interested, okay, again, so this is only a pointer, and I have an example, right? So we are not going to discuss about this much. So there is a module called rparse, and there are some other modules available, but this is one of the useful modules. Okay, so if you look at this, so you should be able to create a method or a function to process your parameters. Okay, so there is a set, you can import this rparse module. So you can set up the code by using this rparse module in such a way that so you can have keyword parameters, and then you can have default values. You can set up some help tests if somebody is trying to run without any proper parameters, right? And some default values if a particular parameter is not passed. Okay, so I will quickly show you a demo, and then I will upload the code. Okay, but if you want to know more, then there is a link here for the reference and then a tutorial, so you can check it out. Okay. Okay. Now I have another one. Okay. So I'm just going to say so we are passing something like this. Okay, so if you remember, this might looks like a Unix command, right? -env is prod, environment is prod, -in file is abc sample csv, and then --has header. The csv file has header or not. So this is how we are passing, and then it says environment is prod, and then in file is this thing. So let's say if I take this and then I will put it over here, right? Yes. Header. No. Right. So still those things are matched. So what happened is I have a script written to read the argv file, and then I do a pop. So remove 2 elements at a time. So maybe I can put this in a dictionary. So in that way, order doesn't matter. So I have a key value pair. Okay, so this is a rudimentary way we can emulate the way Unix statements work. Okay, but it doesn't help us much. This is the rparse module. Okay. So what we are going to do is, so we are going to import the rparse module, and then there is a class called rparser where we can set it up and say, okay, parameters passing using arg. So like some description about your code, and then we will say what are the expected arguments. Okay, add argument has different syntax. So I have extract type and arg level are positional parameters, and then I can pass -i or -in file. That should be your input file, and then -o, hyphen out file, which is your output file, and then hyphen e or hyphen env is our environment. And then there is an email. The default value is mk@abccorp.in. So if you don't pass this email, it is going to have this default value. And then there is a threads. We expect int as a value, and then there is a default. Okay, so if you look at it, line 4 to line 11 describes about what parameters you are expecting and whether they are positional or whether they are keyword, and then a help text about each parameter. And then you can also set type, what type of data you are expecting. You can set default value in case if the value is not passed. So if you don't have a default, then that means you are expecting the user to pass the parameter. Okay. Once you have coded this line 4 to line 11, so whatever parameters you are passing, the argparse will take it, and then once you run the parse args, so it will create a arg list namespace, and then it will put extract type underscore in file out. So whatever you are giving here, right? First parameter, so you have given extract type, arg level, in file, out file, env, email, and threads. So this will be the variables in that namespace. Okay, so this is code. It simply sets up the values. Okay, so when I run this, you will really see in this 30 line how much is happening. Okay, so Python comms 03. I'm running without any parameters. Okay, so see, by default it is showing usage. Okay, this is how you have to use -h or -in file, -out file, -env, -email, -threads, and then extract type and arg level. So it also gives you an error because we ran without any issues. So -h stands for help, which will be produced by the arg parser. So what it says is, hey, this is what we are parsing, right? So this is how you have to use it. And then I am parsing using the arg parser. So I have positional parameters, the extract type, and then arg level. So the value can be state, division, school, district, or whatever it is, right? And these are the optional arguments. Help, we can pass -h or -help, -i or -infile, -o or -out, -out file, so these are the things it states. Okay, so this is something that was generated by the arg parse using these 7 lines. So whatever we have seen, the formatted text is all here. Okay, and it is not all that difficult. So you have the arg parser, you set up a description, you add as many as argument you want, and then finally you do a parse args. Okay, so now let's take it to a spin. Right? So I'm just going to run with what did it say, extract. Okay, it had 2 positional parameters. First is extract type, and then the second thing is arg level. So extract type is, I will say summary extract or aggregation extract, and then I say the arg level is state. I run this. See, all the other things are what it said. They are optional, right? So I didn't pass input file, it put none. I didn't pass output file, it put none. I didn't pass environment. Okay. Email ID and thread will have default value. Okay, so now let me put -e as prod. Okay, and then -i as abc.csv, -output out file as abc.dat. Okay, so now the email ID and the thread count are default values. Let's take this and then email is info@abc.in, thread what is that value? Thread count, threads, right? Threads 100. So it gave me whatever I passed. Okay, so if I say 100A, so now it is giving me threads invalid int value 100A. So if we have to write our own parameter parsing, right? Like so we might have to write 100 plus lines. Okay, but what this arg parser does is, so it gives you ability to put default, make something optional, something mandatory, help text, and like a data type for certain parameters and so on. Okay, and all these things is one line per parameter you want to pass, and then you also have a unique style hyphen something or hyphen something. So in that way, your program is self-documented, right? So either if somebody runs it, it gives you something, or if somebody runs with hyphen help, so it gives you some information. Okay, so it's a worthwhile investment to investigate this module. Okay, so you might want to try this out. Okay, so I think I have already copied okay, I have not yet. Okay, I will copy it after the session. Okay, so that is all about the miscellaneous topic that we want to cover. Okay, and then in the module list, so these are some of the modules that we will be looking at. Okay, and some of the things that I will give you a list of something else that you can actually try on yourself. Okay, so we already saw OS, sys, random, and pprint modules. So we also saw the faker module. Then we will be looking into CSV and JSON to handle file IO operations of CSV and JSON. Okay, CSV is one of the very common file formats, and JSON is something that we could use for as a configuration file, right? So if you want to pass, because what we saw as parameter handling is okay if we pass 5 to 6 parameters. So what if I have a lot of things to set up? Where is my log file? Where is my input directory? Where is my output directory? And then where are certain limits? Like let's say I have some 25 different runtime things that can change, right? So then passing those 25 as a parameter would be a headache. So what I can do is I can create a JSON, and then I can simply pass the JSON, right? My config is this. Then from the JSON, we can read and set up the parameters. And then we will look into the SQLite 3 module to do some RDBML database operation. And then the PEP8 or bytecode style is a tool. No, it's a reporter that takes the script and then it will tell you whether you have any issues. For example, so if I say bytecode style forms03.py, so it is telling. So I have line 4, 6, and 10. So greater than 79 characters, right? And then there is a multiple space before operator in line 13 and blank line at the end of the page. So these are some of the errors. Okay, and then instead of so it simply gives me how many errors. So instead of the line, I have one E22 errors and then one E501 and then one warning. Okay, and you can also say ignore E22 1. Right, so so there is some more errors, right? So if I say help, it gives me a lot of options. Max line length. Okay, so now those errors appear, so disappears. Okay, so the bytecode style has lot of parameters that you can set so that you can get a report. Okay, so we will look into that more. So PEP8 was the old module name, and then it has been changed to bytecode style. So this doesn't change your script, but it simply takes the script and it has all the rules that are coded based on the PEP8 standard. So it will generate a report. So this is part of the Python installation. There is a module called Black. Okay, what that one does is it takes the module and then it converts. Right, it removes all the coding violation and then it converts that and then writes it in line. So that means you might want to take a backup of your code and then run the Black. Okay, Black also has several options. Okay, so line length you can set. So if you have a line that is longer than a particular line, okay, it allows 88 lines, and then you can also set like against which version we are going to run the validation or check, right? And then right, like, so whether you want to run, so you want to include certain text, exclude certain text, and then whether you want to show what errors are there while converting, or whatever it is, right? You want more information. So quiet and verbose are totally opposite. Quiet means less information, verbose means more information than default. Okay. So we will look at some of the scenarios. Maybe we will take a badly written code and then run it through these two, and then see how that formats. Okay, so this might be helpful for you to check your code then and there and get some feedback, so that like over a period of time you don't make that sort of error. And then finally, so these are the two things. I just put a question mark in front of it mainly because I will still be able to show you the results, but we will not be explaining a lot or in depth what these modules are, other than the customary look and then looking into some of the sample methods and variables that are available when we use the pandas and numpy modules. Okay, so that's all I have for today. So